All right, before we get into today's content, let's test what you already know. Here's your scenario. You've been given the 192.168.1.0/24 network. Your manager hands you this diagram and says, subnet it. Branch A needs 50 hosts, branch B needs 25, branch C needs 12, and this point-to-point link between the two routers, it only needs 2 hosts. You know the formula, 2 to the h minus 2 for hosts, so you're ready, right? Here's what I want you to notice. What if you use the same subnet mask for all 4 of these? Because that's what we've been doing up to this point. Stick around, because by the end of this video, you're going to see exactly why equal-sized networks is a problem in this scenario and how VLSM fixes it. This is one of the skills on the CCNA exam that you will absolutely be tested on. Let's prove the problem of equal-sized networks first, because this is where it gets interesting. A branch needs 50 hosts. We need at least a /26. That gives us 62 usable addresses. That works. Now watch what happens if we use that same /26 for everything. Branch B needs 25 hosts. We give it a /26. 62 usable addresses. 37 addresses are wasted. Branch C needs 12. We give it 62. 50 addresses wasted. That point-to-point link needs just 2. We give it 62. 60 addresses gone. Out of 254 usable addresses in this CIDR 24, we've burned through most of them and barely used any. In a home lab, that might not matter, but in the real world or on the CCNA exam, asking you to do VLSM subnetting, it absolutely makes a difference. The problem that we have here is that we're using fixed length subnetting, and VLSM, which stands for Variable Length Subnet Mask, is how we solve this problem. VLSM simply means this: you're allowed to use different subnet masks for different subnets. Instead of locking every part of your network into a /26, you match each network to its actual requirement. The CCNA may test you in 3 ways on variable length subnet masking. You may be asked to design a VLSM network scheme from scratch. You may be given a network that uses VLSM and asked to find the problem or answer a question about it. And the third way is you may be given something like NAT or ACLs, and you think that the problem is asking you about NAT or ACLs, and in actuality, the problem that it's addressing is a VLSM mismatch somewhere. So you really have to know and understand variable length subnet masking, which in the real world is actual subnetting. And you've learned all of the steps up till now to come to this point. So you learned about how to subnet by number of networks, which was the easiest, and then how to subnet by number of hosts, which is a little bit more difficult. And now we're getting into the real subnetting. Maybe you feel a little tricked by that. If you do, I'm sorry, but you've kind of got to go through those other steps to get to this point. You must remember this rule for CCNA subnetting. You must start with your largest network first and work down. So by largest, I mean the one with the most hosts. So start with your network that has the most hosts and line them up to the least host network. That way, your answer will match what the CCNA question is asking you. Let's put this into practice. Back to our scenario, 192.168.1.0/24. We have 4 requirements. First, we've got to figure out our largest network. So our largest network is going to have 50 hosts. All right, now we just use our 2 to the power of h minus 2 formula, and we start with our largest network. 2 to the 6 is 64, minus 2 is 62. We're looking for the 6 here, which represents our host bits. That covers our 50 required hosts for this network, so we need 6 host bits. With 6 host bits, our subnet mask is 255.255.255.192. 256 minus 192 gives us 64. So our block size for this first network is 64. We can start with our first IP address, 192.168.1.0. In the interesting octet, which is the 4th octet, we're going to add 64. That will give us our next network ID. We can see here in this first network that our entire range of addresses is from 192.168.1.0 to 192.168.1.63. Our usables are here at the .1 and the .62. Branch A is done. All right, now we've got to work on branch B. We need 25 hosts for branch B. We just use our formula, 2 to the power of h minus 2. What do we need here for h to hit at least 25? Well, we can get to 32. That gives us 5 host bits. We convert our decimal to binary here in the subnet mask. Our subnet mask for this network will be 255.255.255.224. Now we can calculate our block size now that we know our subnet mask. So we just take 256 minus 224. This gives us our block size for this network. Our block size for branch B is 32. When we add 32, which is our block size, to branch B's interesting octet here at 64, that gives us our next network ID, which is .96. We just subtract 1 from 96 to get our network range for branch B. Our network range for branch B is 192.168.1.64 to 192.168.1.95. This gives us our usable host addresses of 192.168.1.65 for our first usable, and our last usable is 192.168.1.94. Branch B is done. For branch C, we have 12 required hosts. If we use our formula, 2 to the power of h minus 2, we can see here that 2 to the power of 4 equals 16. If we subtract 2, that gives us the value 14, which meets our 12 host requirement. 2 to the power of 4 tells us that we need 4 host bits, so 4 zeros. We put our 4 zeros here in the subnet mask, and then that will calculate to the decimal value of 240. So our new subnet mask is 255.255.255.240 for branch C. 256 minus 240 gives us our block size. Our block size for this branch is 16. We take the value 16, we add it to our interesting octet, the 4th octet. That gives us the value of 112. So branch D's network ID will be 192.168.1.112. From 112, we can subtract 1 to get our broadcast address for branch C. That gives us a broadcast address of 192.168.1.111. Now we just add 1 to our network ID and subtract 1 from our broadcast IPv4 address, and we have our usable host range for branch C. This network is done. All right, we're almost done. Branch D needs a usable host range of 2 IP addresses. We can actually count this out on our hands, but let's go ahead and figure it out the way that we know how, and maybe it'll become more clear for you at this point even. So from our formula, we will need 2 to the power of 2 minus 2 to get 2 for our answer, right? Our 2 here in this formula where we replace the H, that indicates that we need 2 host bits. We'll put our 2 host bits up here in the subnet mask and fill the rest in with ones. Now we can calculate this from bits into decimal value, and we end up with the value 252. So our subnet mask for this fourth network is 255.255.255.252. Again, calculate the block size with the magic number. 256 minus 252 equals 4. So our block size is 4. We'll add the block size to the interesting octet. When we add the block size of 4 to our interesting octet, which is .112, we end up with .116. That would give us our next network ID if we needed one. We don't in this case, so we just use it to figure out our broadcast IPv4 address for branch D. We subtract 1 from .116 and we end up with .115. Our usable host addresses are .113 and .114. That's it. We only needed 2 and we have 2. You can see our network ID here is .112 and our broadcast is .115. Done. We're done. We've calculated out all of our subnet. You can see in this method that we used up to the .116. In fact, stopping just before the .116. So from .0 to 116, that is exactly 116 IPv4 addresses that we've used, where in the fixed length subnetting, we used 248 addresses. So by using VLSM, we saved 132 addresses. That's VLSM doing exactly what it's supposed to do, which is conserve IPv4 addresses for later use. If you're having difficulty with this still, which is totally normal, I mean, that's okay. It takes a lot of time and practice and repetition. Some people see the pattern right away, and I'll say that's usually very few people. And some people, it takes a while. If that's you, don't worry about it. Please don't beat yourself up. I'm going to be including some more practice videos that you can go through and continue to practice at the steps that you're finding difficult. Again, comment down below. Let me know what parts you find most challenging. If I see several comments on the same thing, I'll try to make one video that specifically covers that topic just for you. All right, thanks for watching. I hope you learned something today. You look like you learned something today, and that makes me really happy. I hope to see you in the next video. Bye-bye.